Hi class, this is the second day of 2.6. So we talked about graphing piecewise functions in the first day. Now we're going to use those piecewise functions and we're going to talk about domain and range using both set and interval notation. So take out those notes that I gave you yesterday that you took notes on from that video lesson. It's the 2.6 notes. We have all the graphs on them. Now we are just going to do the domain and the range. Before we jump into those graphs though, we first have to talk about what set and interval notation is. So this, I skipped one, there we are. So starting with problem number 6 here, if we were to look at this on a number line and say, okay, x is greater than 5, maybe in grade school or middle school you saw something that looks like this, and here is, let's say, 0, and so here's 1, 2, 3, 4, 5. If you saw this in grade school and you were to graph x is greater than 5 on a number line, you'd put an open circle right here, and then you would maybe put some shading off to the right, right? If it were to be number 7, x is greater than or equal to 5, you would have saw something that looks like this, very, very, very similar. Here's 0, 1, 2, 3, 4, 5, except instead of an open circle, you saw a closed circle like this with the arrow once again shading to the right, because greater than is obviously to the right. So now, in this class, we talk about set and interval notation as a way to describe how a graph, what the end behavior and the starting behavior is of each graph. So set notation is really quite simple for all of these. You basically just write this down again, except you write the formal terms of saying x such that x is greater than 5. It's basically just writing this down, except writing this x with a bar in front of it. It means x such that. So x such that x is greater than 5. There's our set notation. For number 7, it's just x such that x is greater than or equal to 5. Okay, it's very, very simple. All you got to do is write it down again. When we get to our graphs, it does get a little bit more difficult, but set notation, just writing x such that. Our interval notation, this is more important. I mean, this is something that we haven't done as much. It's not that it's more important, it's just newer to us, so it's very important to pay very close attention to it. So with our interval notation, what we do is we describe the left part of our graph and the right part of our graph. So it starts at 5. This green line starts at 5. So if it starts at 5, I write down that first because that's the starting value, that's the furthest left value. And it doesn't include 5, that's what this open circle says. It's greater than 5, but it's not greater than or equal to. So when it doesn't include it, I write a parenthesis right there. So it's 5, it's parenthesis 5, and then you're going to write a comma. How far to the right does this green line go? Okay? What number is greater than 5? Well, 6, 7, 8, 9, 10, 1,000, 10,000, a million. They're all bigger than 5, are they not? When does this line stop? It doesn't, does it, class? There's no ending of numbers that are bigger than 5, because numbers just keep on getting bigger and bigger and bigger for an infinite amount of time and space. So there's no such thing as coming to a close at the right end. It's just always going to get bigger and bigger and bigger, all the way to what we call infinity. So it starts at 5 and it ends at what we call positive infinity. That sideways 8 is the infinity symbol, and I like to have a positive sign there because it tells me it's positive infinity, not negative infinity. So here is our set notation answer. Here is our interval notation answer. Okay, with infinity, it's always followed by a parenthesis. Okay, we always follow infinity with a parenthesis. And then if it's less than or greater than, what we have is we also have a parenthesis on the other side. That contrasts to what happened when it's greater than or equal to. So listen very close. We already did our set notation. Our interval notation says that we start at the left and go to the right. So left, it starts at 5 again. But this time it can equal 5. So if it includes 5, we don't use this parenthesis anymore. Now what we use is a bracket. So if it's greater than or less than, you use a parenthesis. If it's greater than or equal to or less than or equal to, you use a bracket. Okay? And then once again, how far does this go to the right? Well, there is no stop. It goes on forever and ever and ever and ever and always. So we put positive infinity. So this is the answer for problem number 7 for interval notation. Okay, like I said on problem number 6, infinity is always followed by a parenthesis. Okay, but you have to look at the brackets and the parentheses when it's greater than or equal to. Let's keep on practicing this. Problem number 8, 5 is less than x and x is less than 7. So if I were to put this on a number line, okay, here's 5, here's 7. I know that x is less than 7, so that means it's everything in here. But I know that 5 is less than x, or another way of saying this is x is greater than 5. So it has to be everything to the right of 5. So it's going to be everything in between here. Okay? Those are going to be my solutions. So what we have here is we have less than and less than, so we have open circle, open circle. So now with our set notation, it's very, very simple. It's x such that 5 is less than x, which is less than 7. Right? All you have to do is just write x such that, and you have it made. So in this one, we write x such that 5 is less than or equal to x, which is less than 7. So now for our interval notation. Here's where, make sure you listen very closely here. We start to the left, so it starts at 5. So 5, can it equal 5? No, it cannot. It is less than, not less than, or equal to. So when it's less than, you use a parenthesis. So it starts at 5, comma, how far to the right does this go? It goes right, 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 and bam, it stops right there. So if it stops right there, it stops at 7. Does it stop when it equals 7, or does it stop when it's less than 7? It stops when it's less than 7, so once again you use a parenthesis. And here's our answer for our interval notation. Very similar for this one. If it goes from, once again, whoopsies, if x, or if 5 is less than or equal to x, which is less than 7, maybe you saw this in middle school, where you had a closed circle here, an open circle here, and it was everything in the middle. So once again, if it starts at 5, but this time make it equal 5 because it's greater than or equal to, you're going to put a bracket there instead of a parenthesis. And how far to the right does it go? It goes as far as 7, but it goes to an open circle, so that's when you use a parenthesis. And there's our answer for problem number 9. Do you see the difference between 8 and 9? 8 has a parenthesis right here because it's less, 5 is less than x. 9 has a bracket here because 5 is less than or equal to x. So that's the difference between 8 and 9. Let's keep on practicing this. You guys are going to be experts on this because we do domain and range with every single unit that we do. So when we get into January, February, March, we do this all throughout advanced algebra. So you guys are going to be experts on this. So now we have, here's 5, here's 7, and it's everything in between. So x is greater than 5, but it's less than 7, and it's less than or equal to. So we have a closed circle, closed circle. So x such that x such that 5 is less than or equal to x, which is less than or equal to 7. And we have here x such that x is less than 5 or x is greater than 5. Okay, so now for our interval notation for problem number 10. If it starts at 5 and it goes to 7, 5, 7. Now they're both equal to as well, so they're both going to have a bracket around them. Bracket 5, 7 bracket. There we are for number 10. Number 11, think of it this way here. We have a number line. So at 5, which is right there, we have x is less than 5. So that's this way. And it's an open circle, because it's not less than or equal to, and we have x is greater than 5, so it goes this way. Also an open circle, because it's not greater than or equal to, it's just greater than. So basically x is every single number except for 5. So to write this in interval notation, we go from left to right. So where does the graph start, or where does this blue line, how far left does it go? What number is less than 5? Well, 4, 3, 2, a negative 10, a negative 20, a negative 1,000. There is no end to negative numbers. It starts at negative infinity. So if it starts at negative infinity, that's where we start. Now once again, just like positive infinity always has a comma after it, with negative infinity, we always have, sorry, did I say comma? I meant parenthesis. Positive infinity always has a parenthesis that comes after it, so negative infinity always has a parenthesis before it. So we have negative infinity, and how far do we go to the right? We go up until, bam, right there. We stop at 5. So if we stop at 5, we put 5 right there. Now it doesn't go up to 5. It's not equal to it. It stops just before 5, so we have a parenthesis. Now those aren't our only x values. We have more x values from here off to the right. So whenever we have more values, meaning like if I have to go here, how far do I go, how far do I go, how far do I go, or here, I lift up my pencil, I start here again and go to the right. If ever I have to lift up my pencil like that, what it means is I have myself a union. That U right there means union. So I have more x values. I start once again at the left, so where do I start? I start at 5. It doesn't equal 5, right? So I'm going to put a parenthesis right there. And how far to the right do I go? I go all the way to positive infinity with another parenthesis. So there we have it. From left to right, we're starting at negative infinity, stop at 5, union 5, all the way to positive infinity. Okay? So there's problem number 11. Problem number 12. Whew! X is less than or equal to 5, or 7 is less than x, which is less than or equal to 12. So if this is the case, we just write x such that x is less than or equal to 5, or 7 is less than x, which is less than or equal to 12. Okay, set notation, I think we all have that down. Interval notation. If we look at this one, let's draw our number line again. Here's 5, here's 7, here's 12. So x is less than 5, less than or equal to, so closed circle here, it's less than it. 7 is less than x, or another way of saying that is x is greater than 7, so everything over here except x is less than or equal to 12, so it stops at 12. Less than or equal to means I have a closed circle, and here 7 is less than x, so that's going to be an open circle. There we have it. So now from interval notation, going from left to right, how far to the left does this green line go? The answer is a negative infinity. We always have a parenthesis with negative infinity. Now how far to the right does it go? It stops at 5. Does it include 5? Yes, it does, because it's less than or equal to. So it includes 5. We got ourselves a bracket right there. Now I'm going from left to right. I stop at 5. Bam! I pick up my pencil because there's more x values, and I start at 7, and I go to 12. So whenever I have to lift up my pencil like that, I got myself a union. So make sure you put union there, or that U. Now we're going to start again at 7. Does it include 7? It's an open circle right here, so it does not include 7. So we're going to have a parenthesis. And how far to the right do we go? We end up at 12. Is it equal to 12, or is it just less than? It is less than or equal to, which means I have a bracket. Whew! And there is my answer for interval notation. Last one. If there is no restriction on x, means that it can be any number. There's no number that it cannot be. We say it's all real numbers. So in set notation, we say this. X such that x belongs all real numbers. This is x such that x. This crazy looking E thing means belongs. And this I with an R type of a symbol, this means real numbers. So x such that x belongs all real numbers. That's what that means. So that's our set notation. X such that x belongs all real numbers. Our interval notation is this. If x belongs all the real numbers, here's our number line. Okay, and our x values are forever to the left and forever to the right. Where does my x start? It starts at negative infinity. I always have a parenthesis. Where does it end? Well, it doesn't. It ends at positive infinity. So we end that with a parenthesis. So that's what we have for set and interval notation when it's all real numbers. Okay? A little bit tricky. I want you guys to have a separate video on that so you can kind of chew on that and practice that stuff for a little bit. We'll have a second video talking about graphing with set and interval notation.